given in this fashion, how to find out peak value from that, how to find out frequency of that wave, how to find out value of a quantity at any given time. To do that, this simple example helps you. What is the simple example? A quantity which is represented by I equal to 77 sinusoidally varying 314t omega. Omega is in angular progressing velocity, omega t. It is in radians per second. So 314t. A sample example. Find the peak value, frequency, time period, and instantaneous value at 2 milliseconds. Like that is the question. How to understand this then? To understand this, we have to compare this with the standard identity. I equal to Im sin omega t. When I compare I equal to Im, what is Im value here? 77. What is the omega value? 314. Like this, we have to understand a solution. Suppose a current or a voltage is referred as 77 sin 314t, an alternating quantity by sinusoidal. Then how to find out peak value of this wave? Peak value of this wave, when I compare, Im become 77. You can see here, I compare with Im sin omega t. Compare this over here, Im, which is 77. Then omega is omega here, that is 314. So what is omega? 2 pi f. You can see here, f equal to omega by 2 pi. Frequency of a wave is given by omega by 2 pi, or omega equal to 2 pi f. So from which, when I compare 314 being omega, this divided by 2 pi when I operate, I will be getting frequency of the wave. That you can see, 314 divided by 2 pi stand here as 50 hertz. The wave which is given to you is 50 hertz wave. If that is a 50 hertz wave, how much time it will take to complete one cycle? Time 1 divided by time, or 1 divided by frequency. I will utilize the relationship. So frequency is 50. 1 by 50 give me a time period. 1 divided by 50. Just here you observe one slash is missing here. 1/50. That refers as 20 millisecond or 0.02 second. So it is how we can simply confirm simple example from this perspective. So therefore, when a simple wave is given to you like this way, you can get its peak value, its frequency very easily from the first principle of comparison. Then how to get instantaneous value of this current at any given time? It's very simple. Just take this I equal to 77 sin 314t. In this value t you substitute the given time. What is the given time? What is the value this expression represents? It represents t, 2 millisecond. You substitute t equal to 2 millisecond and work in radian mode. We'll solve this problem once again. I'm trying to show you what is the use of this today. Therefore, t I have to substitute in this position. When I substitute the value of t in the radian mode, if I solve this problem, it represents me 77 sin 314 into 2 millisecond. Complete the bracket, operate it. It represents me 45.24 ampere. This wave is a progressing sine wave. Progressing with what omega t? 314t. But what peak value? 77. So this is how this wave is having 50 hertz frequency at particular time of 2 millisecond. It is showing me a value 45.24 ampere. This is the knowledge we get from this.